sperms waiting for the start of their journey. During sexual intercourse, about 300 million sperms enter the vagina. To enter the uterus, sperms first need to pass the cervix, which is open while the woman ovulates. However, some sperms will not make it into the uterus. Cells from the woman's immune system mistake the sperms for foreign invaders and attack them. Thousands die. Many sperms find their way into both fallopian tubes, but only one tube contains an unfertilized egg cell. While being in the fallopian tube, trying to reach the egg cell, some sperms get trapped by the cilia and die. Only a few of the original 300 million sperms have survived and managed to reach the egg cell, while this one is being pushed towards the uterus. The egg cell is covered with a layer, the corona radiata. Sperms must push through it to arrive at the zona pellucida, the outer layer of the egg cell. They attach to specialized receptors, which enable them to burrow into the outer egg layer. Inside the zona pellucida is a narrow, fluid-filled space which surrounds the egg cell. The first sperm to make contact will fertilize the egg. But how does this process look like if sperms and egg cell are not in optimal condition? The amount of sperms is less. Their agility is massively reduced. They swim slower, which means they struggle longer in the dangerous environment on their way to the egg. When reaching the egg cell, they fail to burrow into the membrane of it. No fertilization can occur. Also, the egg cell's vitality is important for the fertilization process. If the calcium ion mobilization of the egg cell is not high enough, sperms fail to penetrate it. How can couples support and improve their fertility process? Sufficient and regular exercise, abstaining of alcohol and cigarettes, and managing a healthy and balanced nutrition can improve the conditions of sperms and egg cell. But also, food supplements like chlorella and philandrol can be an important aspect to reach the necessary amounts of nutrients to improve the quality of sperms and egg cell. In sperms, myo-inositol activates inositol triphosphate in the calcium channel of the endoplasmic reticulum, which results in more calcium ion output. Myo-inositol has similar functions in the body of a woman. The enhanced calcium ion production fills the perivitelline space with calcium ions. In the important phase of the fusion between sperm and egg cell, myo-inositol causes an improved acrosome reaction and eases the merging process of the male genotype through the egg plasma membrane for the following hereditary fusion.